folks. Welcome out there this afternoon to another specialized segment day. It's one of those days where you get the privilege of just sitting back, relaxing, doing some math. Not able to call in, but you can still send us some stuff on Facebook, through email, all sorts of questions. A lot of times we get that. Get us through on a weekend and we'll address it come next week, all right? Today, relax, let's sit back and do some math, and let's see what we're talking about today, all right? What's going on today, guys? So we're going to mix things up with percent. All right, well, what in the world is that about? That means, sounds like to me, we're going to mix things up with percent. Well, that's just what it said, right? How about percent mixture problems? We'll just put it together and make it one nice smooth movement here. So let's see an example. Let's see what's going on. Basically, the idea of the percent mixture is that you're going to start with a percentage of something, a certain strength, perhaps a somewhat diluted, maybe somewhat strong solution of some sort. We're going to add something to it, perhaps something that'll weaken it or something that will strengthen it, all right? So you're thinking about that. So in other words, we start with a low percent, we add a stronger percent, we're going to get a stronger solution in the end. It's not going to be as strong as the thing we add. It's going to be certainly stronger than what we started with, all right? So it's all about changing. It's all about changing things. So let's look at this first problem. A mechanic has 30 pints of 80% antifreeze solution, all right? How much water should be added to make a 60% antifreeze solution? So in other words, here we've got a dilution problem. We're going to try to dilute this 80% antifreeze solution. So let's kind of see what's going on. First of all, we're going to take the storyline here is that we're going to start with an 80% solution. All right, and we are going to add water. And we're going to come up with a 60% solution. Just look at it that way. That's what's going on. So in other words, this water diluted it. It brought it down somewhat. Now you say, well, Ernie, what percentage of antifreeze is in water? I hope everybody can answer that one real quickly for me. If you got real water, there should be no antifreeze in there, all right? So that's going to be a 0% solution in terms of antifreeze. So that's what we're doing. We're taking 80%, adding 0%, and coming up with a 60% amount. Now you say, well, how do we know where to go from here? Let's fix the next part here. We've got 80% of how much? That's our important number, 30 pints. So 30 is going to go right there. How much water are we adding? We don't know. We'll call it X, all right? How many pints? We'll find out, okay? Now, out here, you say, what are you going to have? We got another equals here. We're going to have 30 plus X, all right? Now, when we have 30 plus X and we have 60%, that means we're going to have to multiply these out, okay? We've got to make this now work into a nice, easy equation for us to figure out. Remember what I said about water? 0%, okay? 0%. So that's going to be important because what we're going to do, we're going to take a percent of 30. It's going to be 80% of 30. We're going to take 0% of X, which is real easy because there's nothing there. 0 times X is 0. And then we're going to take 60% of this final quantity. So we're going to put a little parenthesis around it when we work through that. So let's change these percents into decimals and let's set up an equation. So we got 80%, which becomes 8/10, or like sometimes we like to call it 0.8. But you can put 80 hundredths here, but be sure that you don't write it 0.08, all right? Now we're going to multiply that by 30. We say we're going to have 0 times that X, clean it up, and underneath this over here we're going to pick up 60%. We're going to write that as 6/10, and we're going to have 30 plus X to value through that. Now, that's kind of crazy, but all we did, folks, we multiply, we multiply, we multiply, and we make one nice equation, nice big equation here. By the way, this goes away, so we don't worry about it. What we will worry about is what is 8/10 of 30? It's going to give us 2 4/10. And we're into decimals, that's okay. So 2 4/10 is going to be 24. But it's going to be 24, friends. Yeah, let's go with 24 and put a 0.0 just in case you're worrying about the decimal place. So it's going to be 24 there. Now, if that had been 3, it would have been 2.4 or 2 4/10. This is gone. So what do we got over here? We've got to distribute again. This is going to be a distributive property moment. And we have, wow, looks like 18 because we say 6/10 of 30. 6 times 3 is 18, and the decimal place is going to work out with that 0 taking care of us. And we've got 6/10 of this x value. All right, so all of a sudden this is not so hard to look at. It's not so hard to look at. In fact, let's do this. Let's go and subtract 18 from both sides. And we're going to have 6 over here, and we're going to have 6/10 of x left over here. And to the calculator, just to make sure, because we're dividing by decimals, we should get a fairly good number out of this. So we'll take 6 divided by 6/10. And let's see what we're going to add, my friends. We're going to add 10 pints, it looks like. So x is 10. And remember, oops, that's a bit off the page. Let's go out this way. X equals, and that's going to be 10 pints. Now, the question is, will it work? Will it work? All right. So let's see what happens. If we add, basically checking back through this equation right here, we have 24 here, still plus 0. Over here, the question is, will we get 24 also? Well, we have 30 plus 10, which is 40, and 40 times 6/10 is 24. So yes, we end up with 24 pints of solution in the end, and we start out with 30 here, and we end up, did I say 24? I'm sorry, we should end up with 40 pints of solution, all right? It takes 10 pints of water, but we're going to add that to the 30, and that's going to give me 40 pints of solution in the end there. So there's your story. Again, 30 plus 10 will give us 40. All right, so there's your final check. That's your way to check it through. It does make sense. It does make sense there. All right, let's look at a different style of problem here. It's still percent mixture, but it sounds like here we're going to start with a craftsman has 40 grams of silver alloy that is 15% copper here. All right, so with 15% copper, that means it's 85% silver. Keep that in mind. All right, so we're looking at what part of copper? An alloy, by the way, is a mix, all right? So it's 15% copper, 85% silver, all right? It says how many grams of pure silver, that would be 100%, must be added to make that alloy that is 7.5% copper. Now, that would make 92.5% silver. But we could look at it two ways. We could go with 85%, plus that 100% is going to give us 92.5%. It's one way of looking at it. Also, we could look at it this way as saying 15% plus no copper. In other words, pure silver has no copper, so we go with 0%, and then we end up with 7.5%. I'm going to go with that because the numbers are a little bit easier, a little bit less crazy, and we're going to set it up very similar to the problem we just did. All right, we're going to first start off with our percentages. So we're going to say we got 15%. This is copper. We're going to add it to pure silver, which has no copper. All right, so we have 0% copper. And that's going to give us 7.5% copper. Okay? So that's our story. That's our deal. All right? That's the first thing we got to do. We got to take this thing and make it into a story. Again, we have 15% copper, adding nothing percent per se, 0% copper. And we end up with this amount here. So again, it's a diluting of the copper. It's increasing the silver. It's strengthening the silver, but it's diluting the copper, all right? So let's see where this is going to go. We start with 40 grams. So here we go. We have 40 right there. We pick up, call it X. We don't know how much, but we're going to add some copper. And actually, we're going to add some pure silver there. And then we're going to end up with, guess what? 40 plus X. There we have it set up. Now, let's play it out here. We're going to change these percents to decimals. We're going to work this one out. And by the way, we'll just draw a nice little line there. This is going to give me 1500ths times 40. All right. We're going to take our 0 again times X, which is nice because that just wipes out. And over here we have, make sure we do this one right. It's going to be 0.075. That's 75 thousandths. Because remember, you move your decimal two places when you're changing there, so be careful. Don't write 7500ths. You'll have a very interesting situation. It will not be a good one, let me put it that way. And we put our 40 plus X right down there in parentheses because we're going to distribute that through there, okay? Now on the left-hand side, what do we got going on here? Well, we're going to say, well, basically it's 15% of 40. And let me see just a second. Let's see if we can get that to come up here. Let's take it out here. See what we got. 15% of 40 should be about 6. Let's see if that works out. It is, equals 6, yes. On the other side here, we're going to distribute. And this is where I definitely want to make sure my calculator is working good for me. Let's go back to 75 thousandths. That's got to have that right decimal place. Times our 40. And we get 3. We get 3. That's pretty cool, all right? By the way, we have a decimal going on over here still. We have this 75 thousandths times x. So we will be needing to do a little graphing calculator division here in just a moment, but let's work a little first. Easy part, subtract 3, both sides. There we go. Wow, we got a 3 left on the left-hand side. What have we got left on the right? We got this crazy-looking x. And at this point, we are going to take our 3, and we're definitely going to the calculator on this one. We're going to take a 3, we're going to divide it by 75 thousandths. And see what we come up with. We come up with 40. So our x value here is going to equal 40, and folks, this is grams, okay? And by the way, it's grams of silver, okay? It's grams of silver that we're going to have to add. Now the question is, will that make the alloys work here? All right, well, we simply do this. We put our 40 in here. We already know we're supposed to get 6 over here, all right? So if we add 40 plus 40, 40 plus 40, it's going to give us 80. So the question is, if I multiply 80 times 75 thousandths, will I get 6? Well, let's find out. That's our check, by the way. We're checking on this. So we're just going to say 80 times 75 thousandths. Put that 0 in there, otherwise you're going to have we're going to be way off. The question is, do we get 6? We get 6, so that works. So that checks back through here. So the answer is, how many grams of pure silver must be added? That would be 40 grams, 40 grams. And you can always go back and check, does the answer make sense? So there you have it, our first and second problem, percent mixture. Real stuff out there. By the way, you may wonder, well, why do we worry about that 7 5/10%? Because that's how you get sterling silver. It has to have that amount, 92.5%. Silver in the alloy makes sterling silver. So there you go. I always thought sterling silver was just absolutely pure, but it's allowed up to 7.5% impurity there with the copper. Just a nice fact. Another reason why we do a few real-world applications here on Mathline. Let's take a look at our next one. Speaking of real world, let's talk about some investments, all right? Let's invest some money in a stock that pays 5% return and twice as much in another stock that will pay 8% return. Now, if annual return is $315, how much are we investing in each? All right, this is where we kind of think fairly well here also. We're taking 5% interest, and we're going to get 8% interest, and we're going to end up making $315 for 1 year. Now, that's our goal. Maybe that's our strategy. How much we want to make, $315. It could be any arbitrary number here, but we picked $315. What that's saying here, and also some of you are noticing, well, Ernie, why don't you just put it all in 8%? Well, maybe 8% has a different stipulation. Maybe it's a higher risk. Maybe it's more difficult to earn that money back. Maybe there's a chance you could also lose money. Those are things that we look out for, and maybe you can't get access to that money as quick as you could at 5%. So anyway, we mix it up. But our hope is that by diversifying, it's a nice word we use in the business investing world, that we can use both of these to come up with what we've got going here. So let's make our percents. We're going to say 5% plus 8% gives us a total interest. Now you say 5% of what? I don't know. All right, so we're going to do a little defining of variables here. We're going to say x equals, in this case, we're going to let x equal the amount we put in 5%. And we're going to double that amount for the amount in 8%. So we're going to have 2x equaling the amount in the 8%. All right? Now, when we look at that, you say, well, Ernie, how much are we going to have? Well, we got to change these little guys two decimals and multiply. So in other words, we're going to take 5% of x, 5% of x, which is going to give us, change that 5%, move the decimal 2 places. We get 5 hundredths. So you got the 0 between the 5. Do not put decimal in a 5, okay? We've got a 0, 5, 0.05 we like to call that. That's 5%, 5 hundredths, all right? And we're going to multiply by our x, since we don't know what that is. We're going to take also over here our little guy. What is that? Y'all got it going here? That's 8%. So we're going to change it to a decimal. Change it just like that. What are we multiplying? We're saying 8% of 2x. So we're going to put the 2x right in there. And then we're going to add those up, and we're going to have $315 out of this thing. All right, isn't that great? We're going to make money. Going to make money. Let's see how it works. We have 5 hundredths x, which didn't change any. Now let's multiply this out and go ahead and get this rolling. That's going to give me 16 hundredths x equaling to 315. Now, this looks like easy algebra, doesn't it? Just add like terms. Add your like terms. You've got 21 hundredths times x. You get, ooh, Ernie, we got to divide by that? Yeah, we'll do that. We'll take care of that. Equals to 315. That's why I have a calculator. Let me clear it out here first, and we'll go visit our calculator here. Let's do some division. We got 315. We're going to divide by 21 hundredths. And we're going to hope that comes out something. Oh, that's $1,500. Isn't that nice? Now, you say, what does that stand for? That stands for X. That stands for X. So this is dollars. So we put 1,500 in the first account. That's 1,500. That's what X is worth. So we're going to put 1,500 in there. In the second account, we put what? Twice as much. So we're going to double 1,500, which is going to be 3,000. Now my question is, and your question should be, do we get $315 in interest for 1 year? You say, well, really? What are we going to find out? We're going to take, and we're going to go to the calculator. We're going to see if this worked. We're going to take 5% of, which means we need to put a decimal in there. Excuse me. How about it? Decimal 0.5. And we're going to multiply that by the amount we put in there, which was 1,500. So put in that 1,500. There it goes, my friends. You got it? All right, let's see how much we got there. Enter. $75 you make off that account in 1 year. Let's check out the other one at 8%. You put 3,000 in there. So we'll put our decimal, the 0.8. Be sure you put that decimal in there and the 0 following there. Otherwise, you're going to make a lot more money. I wish you could make it that way, but 80% and 8% are a big, big difference. Let's put 3,000 in there to multiply by. And we're going to have 240. Now, the question we're probably all wondering, do those two add up to 315? For those of you who doubt me, let's see. Put a plus there. We'll take that answer. By the way, that's taking that 240 right there. And we're going to add 75 to it. Looks like a 315 moment to me. And it is $315. So does it check? Yes, it does. We get $315 back for our investment amount. Now you can say, well, Ernie, what does that mean you're going to have in your bank accounts or stock accounts here per se? Well, over here you're going to have 1,575. Over here you're going to have what? 3,240. So you've made some increases, some nice increases there, okay? You keep running that for another year and another year and another year, you get more and more money. You get the idea. Stocks are a little bit more variable, though. They don't always do the same thing year after year. But if you look at the average on the long run, they can be some good investments. They can also be some very, very heavy risks. So take care, be smart, invest wisely. It's good things to say, all right? Now, with other problems that we got here, we've talked about money. We've talked about silver, gold. No, not gold, but silver, copper, those kind of things, mixing. We talked about antifreeze. You can make salt solutions. You can make saline solutions. You can do all sorts of different type things where you mix things. Let's look at one more mixture here. How about it? Let's mix some perfume together, all right? So in other words, we're taking, it looks like, two perfumes. One is fairly expensive. One is not so expensive per ounce. But we're going to mix to get 3 ounces of perfume. And that's a little bottle, okay? But that's the way they buy that perfume, those ladies. And we guys who buy cologne, we buy little bottles and stuff too, all right? So it's about small sizes here. So we'll probably see some decimals coming out of here. But let's talk about this problem, first of all. It says she wants to create 3 ounces of perfume that cost $68. All right, so we're going to look at $68. We're going to mix 2 perfumes, all right? So the game plan here is 3 ounces and our cost is $68. We mix 2 perfumes. One is costing $38 an ounce. One is costing $18. Let's do a little bit different on this one. Let's use 2 variables. How about let's use X and Y. So let's define it. X is going to be our amount. By the way, this is in ounces, okay? It's going to be our amount of $38 perfume. And our Y, why not? Why not? I like that. That's pretty good. Our Y is going to be the amount of $18 perfume. And you say, well, what are we going to do with that? Well, we know we have to have 3 ounces, amounts. So ounces plus ounces gives me 3 ounces. So my first equation, right there it is. X plus Y equals 3. That's all about the ounces. All about the ounces, okay? Now our second event here, all about the cost. If we take $38 per X, and that's what it's costing, all right? And we mix it up. We mix it up with $18 times Y, we got a $68 perfume and 3 ounces of it, nonetheless. Now, we're just going to look at this, we're going to work this like systems, simultaneous equations, if you will. And we're going to decide we need to multiply this X plus 3 by something to make this work out, all right? Underneath here, it's a choice. I would go with 18Y and I'd make it negative. And here's what I'm doing it for. Let's see, we put a negative 18 that'll run through here, and that will give us negative 18x minus 18y equaling, and we got to multiply at 3. Don't leave it out, folks. Don't leave it out. It's going to give us a negative 54. 54 there. Now, underneath that, how about it? We got 38x plus our 18y, and that's going to equal to 68. And I'm beginning to feel good about this. Okay, you say, why are you feeling good? Because the y's are going away. And I'm ending up with not a bad answer here, by the way. I'm ending up with what? 20x. All right, so 20x. Say goodbye to the y. And over here, let's do a little subtraction. It looks to me like that's going to give us 14. Remember, that's negative 54 plus 68. We're going to get 14. You say, Ernie, 20 won't go into 14. Well, it will. It will. It'll divide in there. It goes basically 7/10. All right? So we're going to call 7/10. Right there it is. Now, if that's x, if x is 7/10, you say, well, what's y? Well, we know that x plus y equals 3. Right? We're going to use the easy equation here. So we're going to put in 7/10 of our x plus this y, and we're going to get 3 out of that. Well, subtract. Subtract 7/10 off, and you're going to get y equaling to 2 3/10. Now, again, we're going to go trust the calculator for us a little bit here. We know that works. We know that first part works. They add up to 3. What we want to do is check out this cost, which is a little bit more off the wall. So we're going to take our 38. That's the more expensive perfume, and we said we had 7/10 of an ounce. So we're going to say times 7/10. So there's our cost there. This looks like about $26.06. And then we're going to take this 18 times 2 3/10, our other size. Check what we've got here. I got 26 6/10 plus 41 4/10. Let's see if it gives us 68. I believe it does. I see 68 coming our way. For those of you who are my little doubters out there, let's do it. Let's put a plus on there. Answer plus. How about it? We'll take 26 6/10. In other words, that's $26.60. And we got a $68 bottle of perfume for 3 ounces. Right there it is. It checks all out. So there's your cost right here, 7/10 of this, and 2 3/10 right there. And those are ounces. Okay, so there we go, a little bit of percent mixture. Hopefully you saw some good practical examples today, all right? And speaking of practical things, we love Facebook, all right? We love it when you like us there. www.facebook.com with that / of TNLearn. Of course, Mathline at TNLearn.org. Give us those questions, give us those things that you wonder, and maybe even things you want to ask about the show. Don't forget, we do these things on YouTube, and a lot of these shows themselves here, these Friday shows and our specialized segments, and hey, summer school is all about YouTube. So there's your page there. Check us out all over the place. We are here. Hey, thank you for tuning in today. Have a great weekend. You know, we're going to be back live this coming week, and we're going to have a great week coming up when you call in, and you can do it next week.